Okay, friends, a little bit more work here. We're going to a little bit more work in Sheets. We're also going to be creating a new formula, which is going to look different than the other formulas. But the basic idea of any formula, and you'll see this over and over again using mathematics, is you have an input or other inputs, maybe more than one. Those are called independent variables, and those go into a formula, and then a dependent variable's value is then shown as coming out. We'll see what that means with respect to my drum set. So I've been using the same drum set pretty much my entire life. As a matter of fact, I'm curious. Sean Rule drums. I love visiting Google. Yeah, here we go. Here we go. So here's that same drum set. This is when I was about, probably 21 years old. You can see they used to be black. I've covered them over. I've painted them green with argyles. Here's the same drum set even before that. That's a lovely picture of me. Probably about 18 years old there. I used to cover them. You can see they were covered in some kind of weird material. I don't know how many other pictures. Oh, there's what it was covered in paper. God, I think I'm 17 or 16 years old there. Yeah, there's me when I was... Okay, enough of this. So I decided to make a fun little math problem out of this. So I bought the drums for $300 back in 1987. So I've had it for many, many, many years. What is the average cost of the kit year after year? So just for example, if I go back and look at just 1987, that means the drums cost me $300. If I go out 2 years, so I've owned the drums for now 1987 and 1988, then the drums cost me on average $150 a year. If I go out to 89, I've owned them for 3 years, then they cost me $100 a year. 4 years, $75 a year. And then I skipped, but you could easily do the math. If it was 5 years, it'd be $60 a year. 6 years would be $50 a year, and so forth and so on. And then I just kept going, and the numbers start getting a little bit goofy after this. 32 years, $938 a year. 33 years, $909 a year. So the first thing I ask you to do is, can you figure out the formula for the average cost? So the idea of averaging, as we've spoken about, the idea of averaging. Averaging means taking something and dividing it into equal pieces. Now, usually, when you take the average of a bunch of numbers, you simply add them all up and divide by how many there are, unless you're dealing with percentages. We've had that talk before, too. So I guess the question for this is, how are you averaging? There's nothing to add. So you can think of it like this. Sure there is. You added up all the dollars that I spent in 1987, and then you're splitting those dollars across how many years I've owned the drum set. So hopefully you noticed 300 split over 1 year is 300. 300 split over 2 years is 150. 300 over 3 years is 100. 300 over 4 years is 75. I mentioned earlier 300 over 5 years is 60, and 300 over 6 years is 50. 300 over 32 is not as pretty, and it's not exact, but it comes out to about $9.38, and 300 over 33 is about $9.09. Then the first question I asked is, can you figure out the formula? What is it? So hopefully you figured it out, that average cost of my drum set is equal to $300 divided by the number of years I've owned it. So the average cost gets cheaper every year because I've essentially mortgaged the $300 over my life. I mean, yeah, I paid $300 back in the day, but now the drum set only costs about $9 a year. So that's just fun. What I mostly wanted to do was I wanted to get into Sheets and actually do the scatter plot and things like that. So let's get back into Sheets. I'm going to use the exact same one we were using before, which is this puppy dog. And we're going to do, let's do drum set average cost analysis. All right, average cost. If I can spell average. There we go, cost analysis. Okay, I'm going to delete this scatter plot. All right, number of years. I'm not going to start at 0 for this one. I'm going to show you a little cool thing here. If you want to get rid of some data, you can just highlight the whole row, right-click, and then hit delete row, and it'll scooch them up for you. And I think I have mine go out to 33, so I'm going to use that cool thing that I did before where I select a pattern, and then I drag it down, and then I get down to 33. And this total cost is all wrong. We have to do equals $300 and then divide by the number of years. And press enter. And then we can drag that formula down. all the way down. So you start to see some of these numbers that we spoke of before. I think I picked the chart up right here, 938, 909, and so forth. Those are all the years in between. So some of those pictures you saw back there from the 90s. So, somewhere in here, the drum set cost me $30 a year. Maybe a couple years later, it cost me $25 a year. Now in my old man years, it only cost me $9 a year. So, okay, so there's your table of the average costs per year. You want to do a scatter plot. So we're going to select these puppy dogs. Oops, I went too far. Sorry about that. Select them. Insert. Chart. It's going to give me its suggestions. Line chart. We're going to go with scatter plot. Did I go right by? I went right by it. There it is. There we go. And it's an interesting one. And I think the next question I asked is, how does this look different than the others? And hopefully you can see, well, first of all, it's not a diagonal line going upward like the total costs were. It's actually going down. But that makes sense it's going down because we're taking a fixed number of 300 and dividing it over more and more years. So, of course, it has to go down. Another way it looks different is it's curving. It's curvy, not straight. If you want to actually see the curve through these points, you probably want to change the chart to these line charts they were talking about. That gives you a better idea of what the shape looks like. Okay? All right, what else are we talking about in here? Let's see. Create a scatter plot. How is it different? Will the average cost per year ever get to zero? This is a fun question. It's a fun question. In other words, you've noticed, let's go back to sheets here. You've noticed that it keeps dropping, getting smaller and smaller. But you may also notice that it's getting smaller, slower. Like the first drop was $150. The next drop was only $50. The next drop was only $25. The next drop was only $15. Then $10. Then $7.14. So if we keep this going, you're definitely going to see the drop continue. Let's pretend I'm a Jedi, and let's go out to, how old was Yoda? I think he was like 700 or something. So we'll go out to like Yoda's age. 585 is good enough. And let's just pretend I can live to 585. And I can own my drums the entire time. Will we be able to take enough years, to divide by enough years, to drop the average cost to zero? And look at that. Now, you might look at that and go, wait a minute, wait, these aren't going down anymore. They actually are going down. Remember, this is rounding off to 2 decimal places. If we actually come up here and increase some of the decimals, you can see they're still going down. They're just not going down very quickly. So then the question is, will they ever go down to zero? Can they get to zero? So what you might do at this point is you might try some numbers like, what if we did 300 divided by 10,000? Well, let's do it. Equals 300 divided by 10,000. So 10,000 years into the future. That's 3 cents, but it's not zero. It's 3 cents a year. Well, how about 100,000? That's 3.3 cents. What about a million? It's 0.03 cents. And hopefully you're beginning to realize something. It never will be able to get to zero. It can't. Because you're dividing the number 300 up into pieces. More and more pieces. The pieces are going to keep getting smaller. But they can't ever get to zero. All right, friends, go try some homework.